Okay, now we are looking at a hyperbola. So with this hyperbola, they have given us some pieces of information here. They have told us where the vertices are. So we have the location of those. So I think for a lot of us, again, just like the last one, it will help for us to be able to plot that and try to see what's going on so that we can figure out where we're at. So all right, so if I'm at negative 8, 10 for one vertex, and then I'm at negative 10, 10 for the other, that tells me a couple of things. We know that this is going to then open side to side, so it's going to be horizontally oriented. Also, we know that the center is going to fall directly between those vertices. So this would also tell us that the center of this is located at negative 9, 10. So we know where that's located as well. So if this is the center, the distance from the center to either vertex is A. So that means that we would know that A is equal to 1. And because we know that this is horizontal, we know that we're going to be starting with X. Remember that for a hyperbola, A does not necessarily have to be larger than B. It could be, but it doesn't have to be. Whereas with an ellipse, A always had to be the bigger one because A was coming from the major axis. So just a reminder about that. So we know A. We don't know B at this point. We do know H and K, so we know those from the center. So we have H here and K here. But then we're also given this piece of information that the distance from the center to a focus is the square root of 10. So the distance from center to focus, just like it was for an ellipse, that is C. So really, they have just provided us with C. We have A, which means we do have the ability to find B. For a hyperbola, you are using Pythagorean theorem. So you are using a squared plus b squared equals c squared. In this case, a is 1. So 1 squared plus b squared equals the square root of 10 squared. So we have this, which tells us that b squared equals 9, meaning that b is 3. So that's what we know, which means that we know enough to be able to create the equation that goes with this hyperbola. So x minus h would be x minus a negative 9. So x plus 9 squared over a squared. A is 1, so 1 squared is 1. Minus y minus k, so y minus 10 squared over b squared. So b squared would be 9, and that's all equal to 1. So this is the equation of your hyperbola. Now remember when you're graphing these, that b value, so this b being 3 that you see here, that comes into play when you are creating those asymptotes. So from the vertices, we move the opposite direction that we use to plot them. So we're going to move up 3 and down 3. I'm just roughly eyeballing this on the screen, not really counting too much. Because that's going to create the asymptotes that go through the center of the graph. Remember, they intersect at the center. Oops. So there are your asymptotes, which means that when we would graph this, the U shapes that would make up this hyperbola would be pretty wide in this case. and that would be your graph.